Welcome back. In this section, we'll be talking about putting together the clues that we learned in 5.2, holes, vertical asymptotes, horizontal asymptotes, in order to graph a rational function. So this has a little bit more work to it than graphing a polynomial, and that's because rational functions, their graphs are a little bit more complicated than polynomial graphs. First off, we should always start by thinking about our domain and factoring our function and simplifying it as much as possible. And at that point, start thinking about things like the locations of any holes that happen to be there. So once you find them, plot their coordinates, and then next, we can then start thinking about asymptotes, vertical asymptotes and horizontal asymptotes. Remember that both of those you would need to draw them as dashed lines. You would also need to label them as an equation. One thing also that you might want to do, which is that if you are looking at a horizontal asymptote, you might want to find out, does the function ever cross that horizontal asymptote? Because remember, it's possible that somewhere in the middle we might. So if you happen to know that you've got an equation of a horizontal asymptote, you would just need to find out where is your function equal to that value, and if you can find any solutions, then those would be values of x where you cross your horizontal asymptote. Now, once we've talked about our asymptotes, then we move on to our intercepts. So finding all of our intercepts, X-intercepts, and if there's a Y-intercept, find that as well. The Y-intercept, you find that as always by putting in 0 for x. For the X-intercepts, remember that for the X-intercepts, you'd be looking for the function to be equal to 0, but that means you would have a rational expression, some fraction being equal to 0, and that's only equal to 0 when the numerator is equal to 0. So that's why I say here that the X-intercepts are the zeros of the numerator. So if f of x were, for example, x minus 2 over x minus 1, then the only X-intercept you would have would be when x is equal to 2. X being equal to 1 is not an X-intercept. In this case, that would be a vertical asymptote. Just like we had before for our polynomial functions, we can also talk about the behavior of those x-intercepts. Are we crossing the x-axis there, or are we touching the x-axis there? And it's the same reason as before, based on just the multiplicity for those zeros. The last step here I have in 5, this is something that you may or may not need to do. Unlike a polynomial, which is one nice smooth curve, so you could put together all of your clues and come up with your graph of your function, it's possible that you might not have enough clues to graph a rational function. So you might need to know in which regions or which intervals is our function above the x-axis or below the x-axis. So here, the suggestion that I have is we might want to make a number line, and on our number line, put in any of the values that make our numerator 0 and any of the values that make our denominator 0. And that means that our number line would be split into regions where we could be either always above the x-axis or always below. And then we could use test points, selecting values inside of each of those intervals to find out, is our function above the x-axis or below the x-axis at that point. Now, we might not need to do that totally systematically for these sorts of problems. And in fact, maybe we only need a single test point to be able to find out what's going on. Just beware that that might be a possibility, that you might not, with the clues, the holes, the asymptotes, the intercepts, that might not be enough information to graph your function, so you might need to take a few well-chosen test points to figure out what's going on. And of course, if you're taking any extra points, you need to plot them and label them on your graph as well. And then finally, sketching your graph. And much like I said for graphing polynomials, we have to put together all of our clues in a way that they don't contradict each other. And so sometimes as I'm graphing, it might not feel like I have enough information, but I'll ask myself, if I did this with my graph, Would that contradict something I found earlier, or would that confirm what I found earlier? So let's take a look at a nice rational function here. G of x, relatively straightforward because it's already been factored for us. And we can see that the x minus 3's here cancel. And so we can say a bunch of things about this, starting with there is going to be a hole that is on this graph when x is 3, because the x minus 3 was a factor, and that factor was able to be canceled out. And we can see that the y value when x is 3 for our hole should be 7/2. So the point 3, 7/2, that will be a hole on my graph. I'm going to plot this now before I forget. So at 3, 7/2, 7/2 is 3.5. So at around here, I'll draw myself a little bit of a hole, and I will label it. I might have to adjust the location of my label later on, but I'll label it now. I might have to move it over to make room for the graph, but we'll see what we get. Next, let's think about our asymptotes. For the vertical asymptote and the horizontal asymptote, vertical, we can see that there definitely is one. X minus 1 was a factor of the denominator, and it still is. So that means x equals to 1. That would be my vertical asymptote. For my horizontal asymptote, we can see that the numerator has a degree of 1, and the denominator also has a degree of 1. So for the horizontal asymptote, this would be one of those where the horizontal asymptote is the leading coefficient for the numerator over the leading coefficient for the denominator, or the line y equals 2. So now I'll plot both of those. I'll put in my vertical asymptote and my horizontal asymptote. Vertical asymptote was x equals 1. And my horizontal asymptote was the line y equals 2. And as I usually do when I do these sorts of graphing, my horizontal asymptote, I only draw it at the far left and far right. If you wanted to continue putting in the dots all the way in the middle, you certainly can, but you don't have to do that. Because, of course, remember that our horizontal asymptote is what we're tapering off to only on the far left and on the far right. In the middle, there's no restriction of what can go on. Maybe we do cross through it, maybe we don't. And this is a point where we might want to find out, do we cross the horizontal asymptote? And so if we cross the horizontal asymptote, that would happen when the function has a y value of 2. In other words, is it possible for our function to be equal to 2? And if we decide to try to solve for this, we run into a problem right away. Which is that we come up with something that is a contradiction. We come up with 1 is equal to negative 2. And since that's a contradiction, that means that there's no solutions. So the answer to my question, do we cross the horizontal asymptote? The answer is no to that. So I know then that at no point am I going to cross that horizontal asymptote. I tried to find x values where I did, and I found no solution. So that means I never crossed that horizontal asymptote of y equals 2. Okay, so we have our hole. We've got our vertical asymptotes and horizontal asymptotes plotted. The next thing we need to do is think about our x and y-intercepts. So for the y-intercept, this happens when x is 0. So this is where we'll need to put in 0 for x into our function. and that gives me a value of -1. So we have the point 0, -1. For the x-intercepts, that would be just where our function is equal to 0. And of course, for a rational function to be equal to 0, that happens when the numerator is equal to 0, which in this case happens when x is -1/2. We can also see that this has a multiplicity of 1, that -1/2 for x came from 2x plus 1, and that wasn't 2x plus 1 squared or cubed, it was just 2x plus 1. It had a multiplicity of 1, so we're going to cross the x-axis. So I'm going to plot my 2 points that I have. I have my y-intercept of -1. That point doesn't need to be labeled. The other point, however, that point of -1/2, 0, that will need to be labeled. And now we're going to start to put together our clues. I'm going to draw my graph here in a light blue, and I'll show you what I mean about asking ourselves questions. So if we're thinking about what's happening on the far left of our graph, it's pretty clear that if we're leaving that x-intercept of -1/2, 0, as we move further to the left, we're going to get closer and closer to that horizontal line. So at least that part seems to be pretty straightforward. We also said that we were going to cross the x-axis at that x-intercept, which matches up with what needs to happen next. We're supposed to make our way to that y-intercept, and so I guess we have to then cross through the x-axis. There we go. That matches what we were planning to do. And then you have 2 options as to what could happen next. As we get close to the vertical asymptote, either we'd be going up or we'd be heading down. And the question is, which are we doing? If you think you're heading up, then that would mean you would need to have an extra x-intercept, and we don't have one. This is what I mean about all of our clues have to be consistent with each other. So I know that there's no x-intercept there, which means I can't be going up, which means I must be heading down. This looks a little bit lumpy, so I'm going to just redraw that and make it look a little bit smoother. But the overall shape then, on the left side of my vertical asymptote, is that kind of a shape. And as we get closer to that vertical asymptote, we become closer and closer to a vertical line. All right, so now the right side of our vertical asymptote, what's happening there? Now, we don't have any other points on the graph, although we do happen to have this hole. And one of the things with holes would be that we get close to the hole, then we skip over it, and then we continue on in whatever direction we were heading. So we know that at least some part of our graph is in this area. Now, we know that we've got a horizontal asymptote, so it makes sense that after this point we would have to taper off and become horizontal. We couldn't go down and cross because we already found earlier we were not going to cross the horizontal asymptote. Also, we don't have any extra x-intercepts either, so definitely we must be heading downward. If you're thinking about what happens between the hole and the vertical asymptote, again, there's 2 options. Maybe you're heading downward, or maybe you're heading upward. If you were heading downward, you would need to have an extra x-intercept, which we don't have. So you can't be heading downward, so therefore you must be heading upward. And there we go. So that is our function, f of x, now graphed. I just need to label it, and I'll label it with its equation. Now I'll do it over here. 2x plus 1 times x minus 3 over x minus 3 times x minus 1. There we go. That's my function with all of the important points labeled. So I've got my hole labeled. I have my x-intercept, that -1/2, that was labeled. I have my vertical and horizontal asymptotes also labeled. and I've got my equation labeled. Let's do another one. This one I'm going to do a little bit of factoring to get myself started. The numerator, I can take x squared out as a common factor. And what's left over, the x squared plus 3x plus 2, that factors as x plus 2, x plus 1. And so the x plus 1's cancel, and now we can say a bunch of things. Number 1, we have a whole that happens when x is equal to -1. And if we wanted to find out what the y value is, we put in -1 for x into our simplified version of our function. And we wind up with -1/2. So the point -1, -1/2, that will be a hole on our graph. And I'll plot that in just a moment, but while I'm here, I also want to talk about vertical asymptotes and horizontal asymptotes. We can see that we've got a vertical asymptote, x is equal to +1, and that's because there's the x minus 1 that's still a factor in our denominator. And that as far as horizontal asymptotes go, there are none. And that's because for this rational function, the degree of the top is larger than the degree of the bottom. And again, for horizontal asymptotes, whether we're looking at the unsimplified version or the simplified version, it's still the same. The degree of the top is larger than the degree of the bottom, so no horizontal asymptote. So I'll just put in what I've got here, my whole and my one vertical asymptote. Vertical asymptote, x is equal to 1. And my whole, which was at -1, -1/2. Okay, so part of my graph already done. Next, let's think about our x-intercepts. So for our function that we had, and when it was simplified, f of x simplified to give us x squared times x plus 2 over x minus 1. And for that, you can see that there are two zeros. We cross the x-axis when x is 0. We cross the x-axis when x is -2. And when x is 0, that came from x squared, that has multiplicity of 2. That means that at that point we are going to touch the x-axis, not cross it. X being -2, that came from the factor x plus 2. That had multiplicity of 1. So there we are going to cross the x-axis. So we have our x-intercepts 0, 0, and also -2, 0. Conveniently enough, this is also the y-intercept. So one of our x-intercepts is also the y-intercept, so I don't really need to go and find the y-intercept. I already know what it is. It's 0, 0. So let's plot those points. 0, 0, and -2, 0. And now we've got enough to be able to at least put together part of our graph. So one thing that we know is that from that hole, we should be making our way to those two x-intercepts. We also said that, if we're going back to our multiplicity, that at 0, we were going to touch the x-axis, and at -2, we were going to cross. So that means at -2, we must be crossing, so we must be heading upwards. And at 0, we were supposed to touch the x-axis, so I guess we're heading back downward. I also know that there were no horizontal asymptotes, so the fact that my graph is going up on the far left that's consistent with what I planned. I did not plan to have a horizontal asymptote, so crossing at -2 and keeping on going, that's exactly what I expect to happen. Now, here on the other hand, on the right side of our graph, I run into a problem. I don't have, if you're looking at my graph here, I don't have anything plotted at all. I have nothing going on in this region. I have no points. I have nothing to help guide me. And so some of us might think about saying that our graph is finished. But remember, if we're going back to our original function, if you were asking me what is the domain of this function, my domain is all the numbers except for +1 and -1. But any other x value can be used. That means that in our graph, there definitely should be something going on here. There's not just an empty space. There are values for y when x is 2 or 3 or 4 or larger values. This is one of the places where we're going to need a test point to help us figure out what's going on, because there are two basic things that could be happening. We could pick a test point and find that it's below the x-axis, at which point you could then come up with an idea of what's going on with your graph. It couldn't be going up because that would mean you would need an x-intercept, so you'd have to be going down. You couldn't keep going up forever because, again, that would mean you'd need an x-intercept, so at some point you must turn and start heading in the opposite direction. Or, if you did a test point and found it happened to be above the x-axis, same sort of work you could do with that. You could say, well, we couldn't be going down because that requires another x-intercept, so I guess we're going up. And on the right side of that point, instead of going down, because that would again require another x-intercept, well, I guess we must be making our way back up. So the question really is, if we pick a test point, is it above the x-axis or is it below the x-axis? And so I'm going to pick a test point when x is 2. And once I have that, I'll use it to find out what the y value should be. And then I will plot that point. And I'll be able to figure out my graph from that point onward. So I'm going to select a point of x being 2, because that's in the area that I'm interested in. And so the y value there would be 2 squared, 2 plus 2 over 2 minus 1. Putting that 2 into our function to find out what the y value should be. And this turns out to be 16. So the point 216 should be on our graph. So that means that the point that we have, and unfortunately I did not make my x and y axis big enough to put in the point 216, but this is of course the reason why we're labeling our points, is that we know that our graph would have to be going up. It couldn't be heading downward because, again, that would mean you would need an x-intercept and we don't have one. We can't be going down forever because that would mean we'd need another x-intercept and we don't have one. So from that point, it might go down for a while, but eventually it will have to turn and start heading back upwards again. And there we go. That's our graph of g of x. G of x, which was x to the 4 plus 3x cubed plus 2x all over squared, all over x squared minus 1. Did I remember my function? Yes, I did. Good, I remembered it all. Excellent. So there's our function, nicely graphed. As far as the test points go, you can pick whichever point you like. I picked 216. You could pick an x value of 3 or 4 or even 1.1, something really close to that vertical asymptote. Any point you pick, as long as you're picking it on the right side of that vertical asymptote, will give you enough information to figure out what's going on in that region. Okay, one last one that I want to do. So here I've got p of x, and just quickly factoring this, the numerator factors as x times x minus 4. The denominator, you could take an x out as a common factor, and that would leave x squared minus 7x plus 12, and that would factor as well as x minus 3, x minus 4. So you can see that there's a couple of things that would cancel out, the x's and the x minus 4s, leaving you with just 1 over x minus 3. And so there's a bunch of things that we can say right away. Number one, we're going to have holes at x is 0 and at x is 4. And we can find out the y values for those. Y value of -1/3 and y value of +1. So we have 2 points that are going to be holes on our graph, 0, -1/3, and 4, 1. So I'll go plot those. So there's 0, -1/3, and there's 4, 1. And again, I might have to adjust this afterwards. I might have to move my labels, but I've got myself started out. Next, for vertical asymptotes and horizontal asymptotes. For vertical asymptotes, we can see there's this x minus 3 that remains in the denominator. So x equals 3, that should be my vertical asymptote. As far as horizontal asymptotes, the degree of the bottom is the larger degree. So that means that the horizontal asymptote should be the line y equals 0. So we have a line of y equals 0 as a horizontal asymptote and a line of x equals 3 as our vertical asymptote. And again, whether we're using the simplified version or the unsimplified, the degree of the bottom is larger than the degree of the top. That's the reason why our horizontal asymptote is y equals 0. So let's plot that in. We have x being 3 as our vertical asymptote. So there's x equals 3. And we had our horizontal asymptote, y equals 0. All right. Next thing that we need to think about would be, do we ever cross the horizontal asymptote? So here we'd be wondering, is our function ever equal to that value of 0? And we find out that the answer is no in a big hurry, because if we set our function equal to 0, you'll find that there's no solutions to this, which means that the answer is no. We don't cross that horizontal asymptote. So this is another one where we have a horizontal asymptote and it turns out we don't cross it. Next up, let's think about intercepts. So number one, I would say that there is no y-intercept. And so this would be the point where I'd say, pause the video and think about it for just a minute. Why is there no y-intercept? Remember that a y-intercept happens when x is 0. And if we go back and take a look at our function, you can see that there are 3 values not in our domain. X can't be 0, x can't be 4, x can't be 3. So since x can't be 0, that means we don't have a y-intercept. The other reason why you know that there's no y-intercept is because when x is 0, you happen to have a hole in the graph. So again, 2 reasons that are really connected to each other is because there's no x-intercept because we have a hole when x is 0. As far as the y-intercepts go, we also have, as far as the x-intercepts go, we have no x-intercepts either. And that's because if you tried to let your function be equal to 0, you would find that there's no solutions. Because remember that a fraction is only equal to 0 when the numerator is equal to 0, and the numerator here is always 1, it's never equal to 0. So that means there's no x-intercepts, so that means we have no extra points to plot. Now, this might be enough information for us to be able to graph. And in fact, it is, because if we're thinking about all of our clues, thinking about that first hole that we have, 0, negative a third, there are two options. One option is you could cross through that x-axis and then somehow make your way back to taper off to the horizontal asymptote. But that would require you crossing the x-axis, and we already said that that doesn't happen. And that would also mean that you'd have to cross through the horizontal asymptote, which we also said doesn't happen. So we can't be going further than the horizontal asymptote, so that means that as we go further to the left, we must just taper off to that horizontal asymptote. As far as what happens between x being 0 and x being 3, you could be heading up, but that needs an x-intercept that we don't have, so that must mean that we're instead heading downward. So I guess I'm going to need to redo my labeling here afterwards. I'll put that back in. And there's my point 0, negative a third. There's its label. Good, good. And that's figured out what's going on the left side of that vertical asymptote. What's going on the right side of my vertical asymptote? Well, I've got a hole, so again, I can figure out based on that what's going on. I could either be heading downward or heading upward. Heading downward would require me to have an x-intercept that I don't have, so I must be heading upward. And as far as the horizontal asymptote goes, again, there's two options. Either we taper off to it, or we go down and come back up. But that wouldn't be possible because that would require us to have an extra x-intercept, which we don't have. So I guess we're not crossing the x-axis, we are just tapering off to it. And there we go. There is our graph of p of x. Now, our labeling that I just need to do here, I'll do that very quickly. P of x there we go. There's my function labeled. P of x labeled with its equation. I have the important points labeled. I have my asymptotes labeled. And there we go.